So, starting off, we've got a simple perpendicular vector question, vector addition question using perpendicular vectors, and then we have a velocity versus time graph question. Okay, so we'll quickly go into those. All right. So for our first question, we have a car that drives north 10 kilometers, then travels 3.0. Okay, I forgot to change it here too. Okay, 3.0 kilometers west. So I want to draw my vector diagram of that situation. So here's my 10 kilometer vector. And here is my 3 kilometer vector. Okay, that means that my resultant, representing the total displacement, goes from the starting point or initial position to the ending position or final position. All right, so I will need to know the magnitude of this blue line as well as what direction it is pointing. 1 mark if they've got the diagram correct. All right. If I'm going to find the magnitude of the displacement, then I need to use Pythagorean theorem. All right, so that's going to mean that I'm going to have 3 squared plus 10 squared. Okay, so Pythagorean theorem here. Okay, we'll have the square root of 100 plus 9, right? 109. All right, so we're getting 10.44 kilometers, right? Sorry, yes, kilometers. 10.44 kilometers. Okay, so we'll give them a mark for that. Okay, and that's a method mark. If they have a Pythagorean theorem calculation, okay, give them a mark. Okay, whether they got the 10.44 or not. Okay, the next thing we have to find is the angle here. All right, so theta is going to be found using, at this point I could use any trig function I wanted to, so regardless of what one they use, as long as it's in the right order. Okay, I'm going to use tan, so that's going to mean opposite 3 over adjacent 10. I'm going to go tan to the minus 1 of 3 over 10. Okay, so they can have a mark for that. And that's going to give me an angle of, I think, about 16 degrees. So second tan of 3 divided by 10. Okay, 16.7, so 16.699. Degrees, okay, and that is going to be which direction? West of north. Remember, we tell this by, okay, the angle arc is touching due north. That means the angle is measured from due north. We went west of north. Okay, I'm going to give them a mark for having the direction correct. Okay, west of north there in that calculation. All right, so we're up to 3 here. Now, okay, we need to have our final answer. Okay, so that'll be that our displacement is going to be 10 kilometers. Sorry, yeah, 10 kilometers at 17 degrees west of north. Okay, so if they have that, okay, that's a 4th mark. Where am I missing a mark here? Oh, sorry. This should have been 2 marks. 1 mark for Pythagorean theorem, 1 mark for 10.44. Sorry, that's how we get up to 5. 1, 2, 3. No, I was up to 5 already. Take that back. I was up to 5. This is their 5th and final mark here. Okay, question, Easton.
Don't you have to use significant distance and do 10.4 kilometers at 16.7?
How many significant figures do I have? 2? 2.
Oh.
So my answer can have 2. Okay, so 2 significant figures on the answer. Okay, 10 kilometers has 2 significant figures because trailing zeros are significant. Okay, 17 degrees, 2 significant figures. All right, so they have to have the right number of significant figures here, guys. They have to have units, otherwise the answer is wrong. I don't give half marks on this, so don't give them to them. Otherwise, I'll just take them away. Okay, I mean, I don't mind being the bad guy, but okay, it's just easier if they know what they actually got. Okay, any other questions on that one? Okay. For our graphing question, we want to find the average velocity of the object over the entire trip. So I need to remember that average velocity is total displacement over total time. They got that somewhere, they can have a mark. Okay, that's the crux of this question. Okay, because I have to remember that I'm going to need to use that formula. in order to use that formula, I need the total time and the total displacement. Well, the total time's easy, it's 10 seconds. That's where the graph ends. So that part's easy. Right? But I have to find the total displacement. Because this is a velocity versus time graph, I need to use each section as though it's its own part of the graph. Okay? That means taking the average velocity for each section and multiplying it by the time in order to get the displacement for each part. Right? So that's going to mean calculating the area under the line, essentially, for each part. Okay? So we're going to have 1, 2, 3, 4, 5 marks here, okay, for these sections. This is our 6th mark, and then when we actually get our answer, that'll be the 7th and final mark for this question. All right, so for our first rectangle here, it is it's 30 high by 2 wide, so that's 60. Okay, this triangle is exactly half of that. It's 30 high by 20 or by 2 wide, but it's only a triangle, so 30 meters. Okay, then we've got this triangle here that is 17 and a half high, negative 17 and a half high by 1 second wide, or on the base. Okay, so we'll have 17 and a half over 2. Okay, it should be 8 and a quarter, or 8 and 3/4, sorry. This one here is 8.75 meters, and it's negative. Okay, this one here is exactly the same size, so I'm just going to do that again. Okay, and then I've got this rectangle here that is 1, 2, 3, 4 seconds wide and 17 and a half tall. Okay, so it's negative 70 meters. All right, so 1 mark each for all of those numbers, for calculating those displacements for each section. Okay, and then I'm going to fill in this formula here. Right? Average velocity is going to be my total displacement, which will be 90. That's all the positive stuff I have. Okay, minus 87 and a half. Is that right? Minus 87 and a half. Okay, so I'm getting a total displacement of positive 2.5 meters. Okay, and I'm dividing that by the total time, 10 seconds, right? Meaning that my average velocity is going to be positive 0.25 meters per second. Okay, that's their 7th and final mark. They must have the positive. Otherwise, their answer doesn't have a vector. Okay, the graph goes into the negatives, so we have to have a positive on anything that's not negative. Right? Questions on that one?
Isn't it usually if you don't have a negative, then it's
No, we don't assume. If we don't write a positive, then it becomes a scalar quantity. Yeah, and it's not the same thing.
If you write like in a forwards direction.
Okay, I'll accept forwards, but in the future, unless it specifically says forwards, we want to keep what we have.
Is it out of 8, that one?
It's out of 7. Right? There's 5 sections here, 6, 7.
What was the first one out of?
The first one was out of 5. Okay, any other questions there? All right, so mark out of 12, put it at the top where I can find it easily, hand it back to the person so they can see it, and then I'd like it in a nice neat pile right here, please.